Welcome everybody. I want all of you to open your chat box wherein I have pasted few chat links. First link is of syllabus link. You can check your syllabus over there. In case you have not enrolled yet, no need to worry. You can fill up this payment form and we'll get you in the classes. Of course, you are always welcome. Fill up this feedback and we'll be going to get it through the form. Yes, you have complete right to know about in detail for your batch. You need to click on this all batch detail link. In case you have any further queries, you can always email us at support@olympiadsuccess.com or you can drop us a WhatsApp message on these two particular numbers. Yes, we will be going to go live on the Facebook, so no need to worry. In case you find an internet glitch and you will not be able to join us back via Zoom, you can watch this demo, which will be live on Facebook. All right. So now I would like to invite your mentor at the platform. Her name is Miss Sakshi. She's a wonderful mentor. I am not sure whether you have taken classes from her before or not, but you will be going to learn something very productive and you will be going to love her classes, I'm sure. So she is in teaching profession since so long. So over to you, Sakshi ma'am.
Thank you, ma'am. Hi, students. Good evening, all of you. How are you all? So this side, Sakshi, your science mentor. I'll be taking your science classes. How are you all? I want to know. Very nice. Anaya, Shivansh. Okay, so I hope my association with you will be very fruitful because I believe in making learning easy and fun and at the same time creative for you. Because I believe that science is all about life and it is all about whatever is there in our surroundings and environment, right? So it is very much, it is almost closely related to what we see around us, what we feel around us every day, right? So if we relate our teaching, if we relate our studies with surroundings or environment, so it will be very engaging and fun. So my focus will be completely not on theoretical aspects because you are already doing it in school, right? So the focus will be touching the horizons where you can be practical, where you can become creative and more engaging, where you'll feel that yes, science is a fun and you want to have that fun every day, right? Right or not? Yes. So I hope you will enjoy with me. You will enjoy the classes with me and you want to learn science every day. Okay. Thank you so much. And I have been teaching students from past 6 years on online as well as on offline platform. And I believe in complete child-centered learning. And yeah, so we'll have a demo today. So, and no, I'm sure that it will be fun, right? Then I'll take reviews from all of you. Okay. Thank you.
Thank you so much, Sakshi ma'am. So now we will be going to have a presentation. So be very, very attentive. Okay. So over to you, Megha ma'am.
Thank you, ma'am.
Welcome, Ishan.
All right. I welcome you all on the platform of Olympiad Success. So, Olympiad Success is the India's largest online preparation platform for Olympiad examination. We are the India's first exclusive live classes for Olympiad preparation, one of its kind yearly program that includes courses that matters. We're having 8 courses: School Plus program, mathematics, English, science, logical reasoning, communication, spoken and written, Vedic maths, and coding. What else we provide? We provide one-on-one online CBSE, ICSE, IGCSE, and IB classes from grade 2 to grade 12, and one-on-one preparation classes for various Olympiads. You can meet our rank holders. These are kids like you only. No need to worry. You just need to spend extra 2 hours from regular studies because Olympiad examination is quite little tougher than the regular examination. We're having a live group sessions with around 20 students delivered through Zoom by tutors with significant teaching experience. 2 sessions per week, Tuesday and Thursday from 4 p.m. till 5:15 p.m. IST with 5 minutes of break. This session includes a mix of theory, practice question, doubt session, and discussion on previous year paper. Student will get reading material and practice question, which will be available on the dashboard of Olympiad Success. And student will also get a free access to Olympiad Success platform to practice the topic-wise mock test. So, syllabus is available enroll on this particular link, and the fee of this course is rupees 11,151. It is a 50-session course, and payment can be made by using this link. This fees includes online class, daily reading notes and exercise, practice of previous year paper, and access to Olympiad Success platform. So what else you require? A laptop or desktop with good internet speed, laptop or desktop with camera, and headphones for the better audio clarity. So live classes. The live classes will be from 26th of April 2025. In 2024, Olympiad Success has students from more than 5,000 schools across India and abroad. So this is all about PPT. I hope I'm clear to everyone. Show me thumbs up if I'm clear. All right, I will ask you questions then. All right, over to you, Pooja ma'am.
Thank you so much, ma'am. So kids, be ready to get to know about the dashboard. Let me share my screen with you all. And here you go. So what you have to do, you have to enter this URL, olympiadsuccess.com. You will be directed towards this page. Over here, you'll be going to enter your user tail, which will be carrying your email ID with which you will register with us. Okay. So as of now, I am entering with one of our demo account. So after signing in, you'll get your profile details. Check it in case you find any error, you can update it. Okay. Click on update, it will be updated. Moving on live classes, wherein you'll be going to get your material. Over here, you need to select your subject and topic. Over here, schedule. In schedule, you'll get to know in which session we're going to go which topic. So under this section, you can see there will be test discussion days also. So that means a particular chapter, you'll be going to cover up your mock test paper, and then on the day of test discussion, you'll be going to discuss with your mentor along with your doubts. So once you are completed all your topic, you will be going to practice more, right? So because obviously Olympiads are meant for more and more practice. So in here is a holiday calendar. Holiday calendar is for your reference that you should not miss any session because already we do have festival holidays. Here is a reading material. So in reading material, you will get an idea what all is there in particular topic in detail. Okay. So over here in question papers and answer keys. So over here in the question paper, you'll get your questions. You need to solve it. And there are answer keys also, which you can check it later on. Okay. Because obviously if you'll be giving a test paper loyal form, then only you'll be going to get to know how much score you got. So in worksheet section, you're going to get worksheets where you need to select your subject. And over here, you'll get your worksheets. Okay. So for that, you need to click on take exam. Select this box, start worksheet. So let's say I am just going to show you how you need to fill it. You just read your question and fill the appropriate answer. Click on next. This way you need to fill all the answers. Once you're done, you need to click on finish button. Yes, I've reviewed all the questions. The moment you're done, you can check your performance also. So click on performance button for the same. So over here, subject is there. You need to select, click on view button, and you'll get to know your performance. So we have filled for one answer, which was wrong. So yeah, that's pretty much about it. Let me log out, and the same you have to do, and let me stop sharing my screen. So now we are open for the QA round. If anybody is having any doubt, needed clarity, please drop your question in the chat box. We'll be happy to answer your query. Any doubt or shall we begin? Shall we begin with the demo? Show me thumbs up if you're okay to go ahead. Okay, so over to you, Sakshi ma'am.
Okay, ma'am, thank you. Yes. Yeah, students. So let me know that what you all are doing recently in your science classes. Because today we're gonna do very interesting topic that is very much related to what you have done already and what you are going to do. So let me know, as I can see that most of you have typed that your favorite topics are these days, your favorite subject is physics, right? So today, unmute option is not available to you, but surely in your upcoming classes, you can unmute yourself and ask whatever you want to ask, okay? But you have to be very interactive and lively in the chat box. Or also you can give me gestures, you can give me thumbs up, like all those expressions, okay? Okay. So I want to know, I can see Shivansh, Advik, Ishan, Anaya. Okay. So tell me one thing, students, right? You can see so many things around you. They can be solids, they can be liquids or gases as well, right? Can you name any 5 solid things around you in the chat box? But you need to tell me the things which are actually present around you. Any 5 solid things? Fan, book, bed, table. Advik is saying. Okay. I want to know from everyone. iPad. Okay. What about Anaya, Ishan, and Shivansh? Are they typing? Okay. Laptop, book, pen, glass, watch. Okay. So do you feel that all of these things occupy space or have some mass? Do you feel that? Yes. They have occupied a space and they too have mass. Sugar, salt, laptop, bag, pen. Ishan is saying. Okay. So what do you feel? Are they all occupy space and have mass? Yes or no? Yes. So that's what we call matter. Matter is something that has mass and occupy the space. We see so many things around us every day. They can be liquid, they can be solids or gases, right? So when anything has mass and occupy the space, then we call it matter. Advik, are you present in the class? Advik? Oh, so they are all, we call them matter. So when I'm talking about matter, so there are different states of matter. Usually we talk about 3 states. One is solid, liquid, and gas. Are there any more states which you know already? If you know 2 more states, then you can tell me in the chat box. 2 more states are, okay, somebody is saying heater. I have 2, okay, you have 2 screens. Okay, that's why Advik, I'm feeling like as if you are looking somewhere, as the class is at the front. So I'm feeling you're looking at that side. So that's why I'm feeling like that. Okay. So students, if I'll talk about Earth, our planet is Earth, right? On our Earth, there are rocks, there are mountains, there are water bodies, and there are so many trees, there are so many plants, there is a land area. So do you feel that Earth is also a composition of solid, liquid, and gas? Do you feel so? Our Earth, which is our planet, so is it a composition of everything? Yes. So the point is, if we feel, let me show you. Let me show you this diagram. Then you will tell me. As you can see, Earth, then in front of it, you can see different images, clouds, greenery, rocks, then water also. So what does it mean? It means that matter is everything around you. The earth is one large mixture of gases, liquids, and solids, right? Could you know, okay, could you name any two things that are not matter? Anything which are not matter? What about your feelings, emotions, thoughts, ideas? Do you call them matter? Yes or no? Do you call them matter or not? No. And I saying no. Ishan, no. Obviously, we won't call it matter because we already talked about matter. Matter is something that has mass and that occupy the space. So if we have to talk about these all, then mass and space. Okay. Now let's talk about another scenario, students. So today we're gonna discuss about matter and its properties. So you can see the 5 states of matter. There are 5 states of matter. One is solid, second one is liquid, then gases, plasmas, then Bose-Einstein condensate. So you must be wondering that what are these images of these one? Like students, in our human body, the smallest structural unit of human beings, structural and functional unit is cell. Do you know that? The smallest unit that made our body is cell. Similarly, to make a building, what is needed? What is the smallest unit that is needed to make a building? Tell me. Yeah, quickly tell me. Smallest unit? Bricks. What is needed? Bricks. Similarly, the smallest unit that a matter is made up of, what is the smallest unit of matter? We know that matter is a composition actually. It can be solid, liquid, or gases, and Bose-Einstein as well as plasma. So what is the actual composition? Like what is the smallest thing that a matter is made up of? Any idea? Okay, very nice. Advik, Shivansh, they are saying atoms. Okay. So smallest unit of matter is called atom. And you know, when atoms combine together, they form a molecule. And when different types of atoms or molecules combine, then they would form a complex thing that is called compound. We will understand it by looking at this diagram because this first diagram is of solid. Okay. First is of solid and the second one is of liquid and the third diagram is of gases. So as you can see, students, what can you analyze after looking at this diagram about the particle arrangement of solid, liquid, and gases? Tell me. You can see solid. These are actually the particles of solid which are very closely packed, no spaces. In liquid, the particles have some spaces, some freedom. In gases, particles are freely moving here and there. Right, Anaya? So you can actually see that in solids, they have a proper arrangement. That's why it's very tough to break the solid, right? You can't easily compress them. Can you compress solid easily? Yes or no? Can you compress the solids easily? Okay. And what about the liquids? Like you have seen that, but let's suppose you are pouring a liquid in a bottle or a container. So after some time, you see that liquids take up the shape of container, right? So should you say that liquids have definite shape? Do they have definite shape or no definite shape? Okay, no definite shape. Nice. They take the shape of a container. And what about the volume? Volume of liquids. Do they have definite volume? Definite arrangement of particles and proper space. They occupy the space as well. Volume is related to the space, like how much space is occupied. Are they occupying the proper space? Definite volume or not? Liquids. Solids have definite shape and definite volume. But when I'm talking about liquid students, so liquids have definite volume, but no definite shape. They take up the shape of container. In whichever container you will put them, they will take the shape of the same. Yeah, no. Liquids have a definite volume. Okay. Don't you feel that liquids have definite volume? Let's suppose you are pouring a water into a water bottle. So don't you feel, are there any spaces left in it or would it be completely occupied by the water? The arrangement of bottle, you are filling water into it. So don't you feel they occupy the whole area? Tell me. Don't you feel they occupy the whole area? So why are you saying that they don't have definite volume? They do have. Yeah, so they do have definite volume, but they don't have definite shape. Okay, what about gases? Like you have heard that once we give the space to gas, it will expand and it will spread throughout in a room. It spreads so fast. Have you heard about all these things? Like when we usually get fear by the cylinder, like if in case the cylinder seal would open up, then the gas will escape out in the environment. That will lead to blast as well. That will lead to severe danger or serious accidents as well. So, like if gases would get the space, then they immediately want to escape from that, right? And students, there are so many advantages of gases as well. The gases which I'm talking about, why they just, why gases spread so fast? Why the particles of gases spread so fast? So as you can see the third diagram, you will analyze that the particles are very far away from each other. They don't have any forces between them. They are free to move in all the directions, right? The arrangement and the forces that are holding them are weak. So that's why they spread very fast, because there is no proper force, there is no strong force that is holding them. So students, if you see the gases, so do gases have definite volume or shape? Yes or no? Do they have definite volume and shape? Yeah. What do you feel? Okay, so students are saying no, no, they don't have definite. Yes, obviously. They don't have definite volume, they don't have definite shape. And if we talk about the spaces, then spaces in solids are very less, like almost negligible. And in this, spaces are comparatively more in liquids as compared to solid. And if we talk about gases, students, so they have a lot of intermolecular spaces, right? They are moving freely. Let's a perfume smell spread so fast. And the agarbatti, incense stick, the incense stick that we usually burn to worship God. Do you know about incense stick? The smell of it spread very fast, very fast. Once you place it at the corner, the smell would spread fast. And even perfumes also, their smell also spread very fast. And if something very delicious is cooking in the kitchen, right? So that smell also came very fast to your nose. That yeah, there's something spicy or something delicious is being cooked. So you got the smell very fast, right? Why? Because vapors, it's about vapors, the vapors or gases, they move very fast because they are free to move in all the directions. So they will reach to you as well at a very fast speed, right? Right, students? Okay, now see how are they moving. They in if you see the solids, they are only vibrating at their own position. Can you check out? They are only vibrating at their own position. And if you see the liquids, then liquids, they have some space, they have some freedom. So they will try to move from their position. And if you see gases, so they are freely moving in all the directions in the container. They are striking on the walls, they are striking on each other. So they are moving like this in all the directions. It's all about intermolecular forces. The forces between solids are strongest, followed by liquids and gases. In gases, the forces are weak. That's why they are moving like this. Okay, let's talk about the next situation. Okay, students. So when we are talking about the states of matter, so you name me two states, right? You name me plasmas, and you also named me Bose-Einstein condensate. So do you know anything about plasmas? One is plasma and one is Bose condensate. Bose condensate. Who can tell me about plasma? Yeah, Bose condensate. So you can see in this kettle, water is there and heat energy is supplied from the bottom. So once you are supplying the heat energy, so you can see that blue color vapors are coming out of it. What does that mean? Are liquids changing into vapor by heating? Tell me. Are liquids changing into vapors? What do you feel? Once you are supplying the heat, the particles of liquid gain energy and they are changing into the Shivansh, then they are changing into the vapors. Shivansh, tell me that what is actually happening over here? Like when the temperature has been increased, then we can actually change the state of a matter. Here you can see the liquid changing into gas. And what are you actually supplying? You are only supplying the heat energy. By giving the energy to liquid, you can change into gas, right? And that's how there is one process that occur in our surroundings that is very helpful to maintain the temperature. Can anyone tell me what is that cycle called? In which evaporation, condensation, rainfall is going on. What is that cycle called? There's a cycle in our nature in which the water from the oceans, rivers, seas, lakes is boiling up by sun rays, and that water is getting converted into water vapor. What is that cycle called? It is balancing the temperature of our atmosphere. Okay, very nice. Water cycle. Shivansh, Anaya, Advik. And what about Ishan? Ishan, you tell me. Yes, it is called water cycle. Very good. So water cycle is a cycle in nature in which heating and cooling is going on. So that is the best example to understand the change in state. Like how fastly solids are changing into liquid, then liquid into gas, the gas is again changing into liquid. So we are going to discuss that as well. So students, if you see this, let me just open the next slide. Yeah. So let's check out this thing. This diagram is actually portraying that as we are supplying the energy, you can see the solid. Students, you can also take the example of ice, chocolate, ice cream. When it is in freezer, then it is staying in the solid state, right, Ishan? And once you are supplying the energy to it, like once you have taken it out from the freezer, what will happen? Would it melt down? Would it melt? Obviously. Once you are, because when they are out, so there is an increase in temperature. So ice would melt into water. Chocolate will turn into melted chocolate. Do you like melted chocolate? Do you like that? No. Do you like chocolate in solid form or in melted form? And ice cream in melted form or in proper solid form? Let me know. Yes, tell me. Okay, so students, if you are watching at this, solids are changing into liquids when you are supplying the energy. That's how ice would melt into water, ice creams, chocolates would melt into water. And once you boil, let's suppose you are making coffee, you are making tea on a fry pan, in a fry pan, right? On a gas. So you will see that there are some water droplets that would start boiling, isn't it? The water will start boiling and you will see vapors coming out from the pan. So actually what is going on? That liquid is changing into water vapors and the liquid is changing into gas once you supplied the energy. So it's all about energy, right? Advik, Shivansh, Ishan. It's all about energy. Once you are giving the energy, that results in the change in the state. As you are supplying the energy to liquid, so they are changing into gases. And if you will supply the energy to gases, so they will turn into super energetic particles. They will ionize the particles, the atoms. If you will heat them too much, then they will start ionizing. They will turn into super energetic particles. And what do we call them? We call them plasmas. Okay? Stars are formed from plasma. Even the lightning that occur when the weather is not good, that is also formed of plasma. Can you tell me any other sources of plasma? Like where is plasma used? Yes. Two examples I gave you, tube light and lightning in the sky. So students, if you check out this thing, there's a below diagram. So here the solid changing into liquid. That is called melting. What we call melting. And if a liquid will change into solid, so it means it is freezing. Right, Advik? It is freezing. Once you, and what you need to do, let's suppose, Ishan, you are having a chocolate that has been melted already. And then you want to convert it into solid form again. How will you do that? How will you do that? Will you keep it outside or will you keep it at some place where it can freeze? Okay. So by keeping in freezer, yes. Plasma is also used in rods, very good. So we can actually freeze anything by lowering the temperature. Like if we again decrease the temperature, so things can freeze, things can easily freeze in that situation, right? Right, students? So now tell me one more thing. When I'm talking about a Bose-Einstein condensate. So Bose-Einstein condensate is like when atoms or particles, when they are freezed. Okay. When they are very cold, like they are formed at a very cold temperature. When you're freezing them, like after the solid, if you are again freezing them or supplying the energy to them, they will slowly change into plasma. So they are super cold particles. Okay, let's talk about the another situation. Okay. So what is happening in this cooker? You will tell me. What is happening in this pressure cooker? Heat energy is being supplied, and what is happening actually? Is there any pressure that builds up? What helps in cooking of vegetable? Increase in pressure or increase in temperature? Okay, so you are saying by both its energy is building up as it has nowhere to escape, and so it heats the food more. Okay, very nice. So whatever heat energy you are supplying, so that heat energy is actually roaming inside the cooker. The particles are getting the energy and the pressure would build up. So that's why whistle blow, right? The whistle on the top. Because of increase in pressure, the whistle would blow. And apart from it, with the increase in temperature as well, we can see that we are able to cook the food in the cooker. Okay, now students, very important thing. So let's suppose we have to change a solid to a liquid. So what we call to that process, we call it melting. Changing of ice into water, melting. And you can also call it fusion. What can you say it? Fusion. Now, what is fusion? Fusion means when the solid would change into liquid. And what about the change in liquid to a solid again? That is freezing. And how will you do the freezing? Obviously, by lowering the temperature, doing the reverse of it, right? Shivansh, Advik, Ishan, Anaya? Yeah. So if you want to change a liquid to a gas, so that is evaporation or boiling, right? And once the vapors are formed, so vapors will go high up in the sky. So once they go high up in the sky, so they would face less temperature. There would be lowering of temperature. So would the vapors condense once they go high up in the sky? Would they condense? Tell me. Would those vapors condense? Cool down? What will happen to the vapors? Okay. Yes. Yeah, they would condense. And slowly, after condensation, what is condensation actually? It's like conversion of a gas into a liquid. Then those vapors which are condensed, they will fall on the surface of earth in the form of rain. Okay, so that's how rain is formed. Once vapors would go in the high up, then those vapors will condense, then they will bring rain on the surface of earth. So that is condensation. Condensation means conversion of a gas to a liquid. Okay, when gas is converted into a liquid. Okay, Anaya. Then we have the direct example. Very nice, Shiva. You can always give thumbs up if you understood that. Okay, then we have conversion of solid into gas. We can directly do that. We can directly convert solid into gas. So the conversion of solid into gas is called sublimation. Students, have you ever seen that we like our mothers, they put what we say naphthalene balls, which are white in color. They put naphthalene balls in the beds so that germs or insects won't eat the cloths, won't harm the cloths. So they usually put naphthalene balls in the bed. And after some time, when we see after 1 or 2 months, we see that, oh, they are no longer present in the bed. They disappeared. Have you seen that? And even there's a kapoor, or we say there's a kapoor as well, like which is white in color. So once we start burning it, it will directly convert into vapors. Have you observed it or not? Yeah, let me know. I want to know from you. Yes, so you are replying to me that we have seen iodine. Wait, let me check. So you are saying, I want to see your replies as well. No, okay, you have not seen. Okay. So naphthalene balls are white in color. You can just inquire after the class. And even snow and ice, if you see, snow and ice, they will also sublime directly into the water vapor sometimes. The snow in the air, ice in the air, it will directly sublimes. It directly convert into vapor sometimes. Do you feel so? In hilly areas, in the areas which are more prone to rainfall, snowfall. Yeah. Have you heard about dry ice? Dry ice. Tell me. Yeah, like Darjeeling, yes. Have you heard about dry ice, students? It is actually when carbon dioxide gas is present in the solid form. You know, why do we call it dry? Because it won't melt into liquid. It will stay in the solid state. It is also used in keeping the items cool. And it is all you students you must have seen the shows. You must have seen the movies, the theaters, and the events that go on, right? So you have you seen the white sort of thing that is coming out from the stages? Have you seen that? There's something fumy, white that comes out. Like when singers are performing, when performers are doing that, then there is immediate white split that occurs. What is that? That is dry ice only. Yeah, that is dry ice only, that has been converted into gas. So dry ice is a solid form of carbon dioxide. So it changes directly into a gas and we can see it in the air. We can see it in front of us, right? Very nice. Very good. Okay. So now you see this flow chart. Just check out. So what is happening in this flow chart? First of all, students, this is just a quick recap. Solid is changing into liquid, that is called melting. Can you see that? And liquid changing into solid is freezing. You can freeze the things by lowering the temperature. Then we have liquid. Once they change into gas, that is called vaporization. And you can also call this process evaporation, right? What can you call it? Evaporation. Then students, liquid changing into gas is evaporation. Reverse of it is condensation. Then straight away solid changing into gas is deposit sublimation, and gas changing into solid is deposition. Students, are you able to hear me? Are you able to hear me? Okay. Now you are going to tell me about pure substances or mixtures. What are pure substances according to you? Is there any purity left on our earth in the items? Like whatever we purchase, we buy, we cook, we eat, we consume. Is there any purity left? Do you feel all those things are pure, fully pure? Do you feel so? Like we usually talk about oils that we use, milk that we use. So can we call it pure, or there are some impurities as well? Okay, so yes, Advik is saying yes. So all these things are pure. Mixture is something that is formed by mixing two different things. Mixture means mixing. That is formed by mixing. Pure substance means that is made up of one type of particles. Like if you are mixing if you will ask me that ma'am sugar is pure, then I will say yes, because it is made up of one type of particle. But sugar in Advik, sugar, if you are mixing sugar with something, let's suppose if you're mixing sugar with chapati and making a churi out of it, like a mixture of type of thing. If you're mixing sugar with any other substance, then that is a mixture only. Pure means that is made up of one type of particles. So now you will look at this diagram and let me know water is pure or not. You will tell me, is it pure substance or is it a mixture? Pure substances are made up of one type of particles, same type of particle, but mixtures are formed by mixing different items or things, different substances as well. You can separate the mixtures by physical methods. And sugar, flour, laundry, jello, honey, sand, pizza. Okay, sand, what do you feel? Sand is a mixture or a pure substance? Is the sand a mixture or a pure substance? Do you feel that there is a lot of mixing in the sand? Pure substance or a mixture? Tell me. Soil is a mixture. Soil. What about soil? Sand is also a mixture, Advik, because sand is formed from different items. That there can be rock fragments, there can be some organic matter, there can be some other mineral particles in sand. So we usually call it a mixture because it is formed by mixing different items. Right, Advik? So sand is a mixture. What about water? Tell me, water is a mixture or a pure substance? Yeah. Pure water. Okay, tell me what seawater. Seawater is a mixture or pure? Seawater can we usually say that it's a salty, it contains a lot of impurities, it contains salts and many other minerals. So how can we say it? Yeah, mixture. Yeah. In its pure form, students, we will also discuss these things later on. That if we talk about water, H2O, the formula of water is H2O. It is formed by joining different atoms or molecules. So that's why we call it a compound. Okay, let's just focus on the last question section. Okay, now you will tell me. There are two types of mixture, students. One are homogeneous mixture and one are heterogeneous mixture as well. Okay, now tell me about this. Observe the given processes 1 and 2 carefully and you will tell me which of the following is correct. Water is boiling in a pan. And in second case, water is kept open and it is placed in the sun. Okay. So process 1 is you are just providing the heat energy to the particles and particles are boiling with the speed. And in the second scenario, you have just kept it openly in the atmosphere and sun rays are falling on it. So tell me, bubbles are formed in process 1 while no bubbles will form in process 2. Okay, second option is saying process 1 is slow, but the process 2 is fast. And third option is saying process 1 occur at 100 degrees Celsius. 100 degrees Celsius is a boiling point, Boiling point is 100 degrees Celsius. And what is the melting point, Shivansh? It is 0 degrees Celsius. Melting is 0 degree and boiling is 100 degrees Celsius. Okay. So now you will tell me that boiling going on in first pan at 100 degrees Celsius. While in the process 2 can occur at any temperature. Like the second process which you see in front of you, it can occur at any temperature. So which option would be right? 1 is right. 2 is not right. How can the process 1 is slow? Process 1 would be super fast because cylinder is used, heat energy is being supplied. So it will occur at a fast pace as compared to the second one. Third one, process 1 occur at 100 degree because boiling point will be reached. So yes, while process 2 can occur at any temperature. So what do you feel? Second option is incorrect. And which options are correct, students? 1 and 3 only. 1 and 3. You got it? Just give me thumbs up if you understood this question. Just give me thumbs up, everyone. Shivansh, Anaya, Ishan, Advik. Very good. Some videos are off as well. Anaya, your network connection is slow. Anaya, your video is turning off. That's why I'm asking. It has been turning off again and again. Are you facing some issues of network? Okay. Homogeneous and heterogeneous are also very simple, students. Homo means same, hetero means different. Okay. So homogeneous mixture are the mixture in which particles will mix with each other. Okay, like sand in water, salt in water, sharbat in water. You also consume rasna. You might consume rasna, sharbat, right? So all those things in water will mix with each other. So those mixtures are homogeneous. Hetero means when particles won't be able to mix with each other. Can sand be mixed with water? Can you mix sand in water? Yes or no? Will you be able to mix sand in water? Will you be able to mix oil in water? Yes or no? Quickly, Advik, Shivansh, Ishan. Will you be able to mix chalk in water? Really? Can chalk be mixed with water? Okay, okay, you mean no. Okay. So the mixtures in which particles can be completely mixed are called homogeneous. And the mixtures in which particles won't be able to mix completely and form a separate layer are called heterogeneous. Now, Shivansh will tell me that is salt solution homogeneous or heterogeneous? Would a salt be able to mix with water? Homo or hetero? One by one you will ask. You will tell me. I'll ask from everyone. Is salt solution homo or hetero? Shivansh, what do you think? Homo. Very good. Now it's for Advik. Advik, petrol and water are homo or hetero? Very good. Now Ishan will tell me sand and charcoal are homo and hetero. Sand and charcoal. Sand and charcoal. Okay, I will look at the answer. Very good. Very good. So you said hetero or homo? Ishan, you said homo or hetero? It's hetero, right? Ishan, it will be hetero. Okay, now where is who has left? Why do petrol and okay, now next we have air dissolved in water. air dissolved in water? Is it a homo or hetero? Everyone, all three of you have to tell me. Petrol and water are hetero, very nice. Air dissolved in the water is homo only because air is, we can't see the different particles in air. Or we can't see, very nice. We can't see different things involved in air because they are actually mixed with each other. So students, this was all about today's demo. I hope you understood what we have done today. Just give me a thumbs up if you have understood that matter is made up of particles, different states of matter. Then we discussed that we can actually change the states of matter by supplying energy, by adding the temperature, by removing the temperature, right? So is it all clear to you? Okay, very nice. Ishan, is it clear to you as well? Okay. So should I end the session if it is understood? That's all about today. So I'm going to end the session. Take care of yourself. I hope you will also search for more examples, like how we can change the solid to liquid, liquid to gas. I will ask some examples from you, right? Search and deep dive into more examples, that how gas can change into solid. What are the examples of it? How solid can directly change into gas? I want you to take it as homework. Just think about more examples, okay? Okay, students? Okay, then bye-bye. Take care of yourself. Have a nice day. Bye. Very nice. Shivansh is laughing.